You generate a near-perfect image. The lighting is what you wanted, and the composition is solid. But you need to fix one minor detail. You type a small adjustment into the prompt, hit generate, and the result collapses into something unrecognizable. This diagram shows the calculation process causing that problem. The system lacks object permanence, the ability to hold specific pixels in place. Instead of editing an isolated block, the algorithm wipes the entire grid blank and mathematically rebuilds the image from scratch. Relying exclusively on text descriptions to generate art is equivalent to operating a slot machine. You are feeding words into an algorithm and gambling on a completely unpredictable calculation. Nano Banana 2, operating inside Google Flow, provides a systematic workaround to this randomness. Professional consistency is built by systematically locking down variables until the AI has no choice but to follow your instructions. The first variable we have to control is the camera. Subjective text descriptions like "make it look cinematic" leave too much room for interpretation. We replace these with strict photographic syntax. We specify the exact gear. We request a 100mm macro lens for a tight field of view, set the aperture to f8 for crisp focus, and mandate a 1940s tungsten lighting setup. Instead of vague positioning, we use descriptive geometry. We place a red sphere in the immediate foreground and lock a square chair into the background plane. This forces the AI to respect physical space, automatically calculating the depth of field based on exact coordinates. By combining exact lens data with spatial coordinates, you transition from a passive gambler to a director commanding a precise virtual environment. The second variable is the physical world. Text alone cannot maintain a character's specific facial identity or the intricate design of a prop across multiple generation requests. The reference engine inside Google Flow processes up to 14 reference images simultaneously, tracking 4 unique characters and 10 specific objects. It merges these visual data streams, applying the exact physical features of referenced faces and props directly onto the new composition. But the reference engine does have a limitation. The AI will successfully generate your specific object, but it will frequently drop it into the wrong location on the canvas. To fix this, we use the manual pen tool. By sketching a simple colored block over a specific part of the image, you instruct the AI to bind your referenced object entirely within that drawn boundary. You pair hard reference data with manual spatial sketching. This removes the machine's ability to hallucinate physical placement. That brings us to the third and final variable, the structural DNA. If you generate a complex infographic and spot one misspelled word, trying to fix it with a standard text prompt will scramble the entire layout and destroy the design. This interface demonstrates JSON extraction. The AI translates the image's exact visual structure into raw JSON code. We highlight the single line representing the specific text we need to address and rewrite the string directly. The surrounding visual architecture remains completely untouched. Feeding this modified DNA code back into Nano Banana 2 generates an identical canvas with only the targeted variables swapped. Extracting and manipulating JSON code provides non-destructive control, proving the AI can be managed through logic rather than randomness. We establish the camera angle using strict photographic syntax. We maintain precise character and object identity using the reference engine, and we edit the final output by extracting the JSON structure. Apply these 3 techniques, and the slot machine is dismantled entirely. The process moves from unpredictable generation to a scalable, repeatable workflow. This level of control lets you match precise corporate typography rules, stage reliable e-commerce product layouts, and build out consistent storyboard sequences. By systematically isolating and locking down the variables, you stop hoping the machine guesses correctly. You command it to build exactly what you envision.